first let me summarize all the formulas that we have discussed yesterday. Okay, and one more thing, in the evening session, the study hour time, we have practiced some questions. Those who are missed the class, I will be uploading that in the YouTube, you can watch it. Okay, by today evening it will be uploaded, or by night. Okay, so those who are absent for evening class yesterday, you can watch it. Means I haven't discussed any new topic, only questions related to the previous session. Okay, right. So now the formulas here you need to highlight is, these are the things you need to highlight. First, what is the radius of Bohr? Like in the Bohr model we discussed, like Bohr, like radius of orbit for finding. What is the formula we used? So radius is equals to Rn is equals to 0.529 n square by z. Okay, this is in angstroms, right? So now if units changes, little bit formula like this decimal numbers also changes right now, because we know 1 angstrom 10 power minus 8 centimeters or 10 power minus 10 meters, like that we can say in picometers like this. Okay, nanometers like that. If they change, you need to change the value, I mean the decimal numbers, that's it. Okay, radius is done. Velocity formula, electron revolving in an nth orbit, what is the formula? 2.18 into 10 power 6 z by n meter per second. Okay, so now how many times the velocity of light is greater than velocity of electron revolving in the first Bohr orbit of hydrogen atom? 137 times. Okay, so these are the formulas. You just make a list of these formulas. I will give complete formulas now itself. Write this formula and write this formula if these are done the last class. Okay, see, after completing every physical chemistry chapter, so you need to make one small sheet, small like one formula sheet, like one page. Okay, all formulas should be there, that's it. Okay, by looking at the that page, every formula should come and the model questions also should come to your mind. Okay, that's it. That is how you can make your quick revision. Okay, so don't spend again 2-3 days for completing one chapter during the revision time. Okay, so this is your revision and this is your final preparation. You should think like that for the upcoming crash course, I mean exam. Okay, you just have some 30-40 days of time. Yeah, so the next energy formula, what we discussed, not so please try to write as fast as possible. Okay. Okay, so done with this. Let us first, we'll finish this first. Okay, right. Ee formula rasara. Next formulas. What we discussed about energy formula yesterday, minus 13.6 Z square by N square electron volt per atom. So in the same place, I mean, we have solved maximum number of questions with this formula. This is most important. The next one in terms of joules. Okay, what is the formula in terms of joules? Joule per atom. Okay, so it will be minus 2.176 into 10 power minus 18 Z square by N square. Okay, so now here, sir, electron volt to joules, what is the exact relation means? What is the exact relation means? 1 electron volt you take as 1.6 into 10 power minus 19 joules. Okay. Next one, 1 joule. Okay, so 1 joule is equals to 10 power 7 ergs. What is that? 10 power 7 ergs. Okay, next in calories, 1 calorie equals to 4.2 joules. What is that? 4.2. So you just remember this relation. Again, we will be discussing about this in thermodynamics, in physics and chemistry. So how do you remember this? See, 1 calorie 4.2 joules. It means, you know, jamuns, gulab jamuns, 4 gulab jamuns in 1 katori. So in 1 katori, how many gulab jamuns you are keeping? Now you can remember now. So 1 calorie, 4 jamuns. Okay, you can remember like that. Okay, no confusion. Okay, that's it. Okay, so all these formulas should be remembered, ma. So in joules, what is the formula again? Energy? Minus 2.176 into 10 power minus 18 Z square by N square. Okay. Fine. Next, over. In case the energy of an electron which is revolving in the second Bohr orbit of hydrogen atom. Answer should be in joules, joule per atom. How can you do this? Just ఈ ఫార్ములాలో సబ్స్టిట్యూట్ చేసినా మనకు అయిపోతుంది. How much I told you? N 2 square hydrogen atom 1 by 4. This number divided by 4, that is your answer, final answer. అదే ఇక్కడ వాడితే మళ్ళీ దీన్ని ఇంటూ ఇదంతా చేయాలి. ఓకే, నెక్స్ట్ దిస్ ఈజ్ అబౌట్ 4 ఫార్ములాస్ రాయడానికి గంట సేపా మీకు? Next, done? Okay, please first. Next one, see, what is the next formula I am saying? the time period of a revolution. It means if this is a nucleus, please stop talking. If this is a nucleus, electron revolve around the nucleus in the circular paths na, like this. Okay. So now how much time is taking per revolution, per one revolution of that electron is given by time period, that is T is equals to 1.5 into 10 power minus 16 n cube by z square. What is it? N cube by z square. N represents that orbit number, z represent atomic number. Okay, remember this formula. So this is in seconds. Okay. Next, frequency. See, frequency units you tell me. Hertz or second inverse. Right now, see, if it is seconds, second inverse means reciprocal of this, I can say na. Okay. So frequency of revolution, okay, or revolutions per second is equals to 1 by T. 1 by T means if you do reciprocal of this. Reciprocal of this means what happens? It will become z square by n cube. See, z square by n cube. So this formula upon reciprocal if you take, it will turns into this one. So what are the values we have? Time is equals to 1.5 into 10 power minus 16 n cube by z square. So if I ask for frequency or period of revolution, reciprocal of this, it means it becomes z square by n cube, and this will be 10 power 15, here 6.6. Okay, these are the two formulas, you make the note. Done? Done? Okay. Next, energy formula. Energy for transition, what is that value we have taken? Like this, R, like Rydberg's equation we have taken now, like this 1 by lambda. This is also called as wave number, nu bar is equals to RH z square 1 by n1 square minus 1 by n2 square. Okay, so that's it. What about RH value? 1.1 into 10 power 5 centimeter inverse. Okay, use this. Okay, make note of this formula. See, I have mentioned it as 1.1 just for remembrance. Exact value if you want, it should be like 1.0967. It's better to remember like this. Okay. Okay, done up to here? Yeah. So now the next one, that's number of spectral lines formula we have. What is that formula? N2 minus N1 into N2 minus N1 plus 1 by 2. That's it. It's all about these spectral lines and all. Now what are the limits we have? Limitations we have for Bohr model. It is applicable only for single electronic system, and you know that spectral lines we discussed now, that spectral lines if you place them in the magnetic field, what happens? It further splits. That effect is called Zeeman effect. About that Bohr model does not explain. Similarly, if you place in the electric field, further splits, that is called Stark effect, that is also not explained. So Zeeman effect, Stark effect is not explained. The next one, like multi-electron system, it won't applicable, only for single electron system. Next one. See here there is something called, we are going to study about Heisenberg's uncertainty principle. Okay, so now what this guy says is, we cannot find exact position and exact momentum of an electron which is under motion. But what Bohr model considered? Yeah, so electron revolve around the nucleus in the circular path at a distance r from the nucleus. Like that he is saying, no? It means he is giving at least some precise position. But actually what he is saying, yeah, we cannot find this. So that's, we cannot find like precise position or exact or accurate position of an electron which is under motion. So therefore Bohr model and Heisenberg uncertainty principle are contradictory to each other. It means they oppose each other. He is not accepting his who? Heisenberg is not accepting his Bohr model. Okay, this is also the thing you need to remember. The next one here we have de Broglie's hypothesis, I can say. So what he says is, de Broglie's dual nature, you can remember otherwise. Dual nature means light has two natures, no? So now what is the Planck's Planck's quantum theory we have studied? E is equals to h nu. Okay, and from Einstein's relation what we have? E is equals to mc square. Right now, so this is equation 1, this is equation 2. Okay, from this equation 1 I can write E is equals to hc by lambda also. See, this is energy, this is also energy. Okay, now 1 equals to 2, if I say 1 equals to 2 means what is 1 here? hc by lambda, which is equals to mc square. Right now, so cc you can remove. Now what is the remaining thing? So lambda is equals to h by mc, I can say. Yes or no? Yeah. So here h is Planck's constant, m mass, c is the speed of light we are taking, like photon we are taking. Okay. So now in the place of c I am writing any other particles. If I say any other particle, that particle have some velocity, right? So for other, this is for light. This is for what? For light. So in case of light or photon you can say. For any other particle, for other lighter particles, it means low weight microscopic particle, lighter microscopic particles. What we can say? C is equals to V. V means what? Velocity or speed of that particle. Okay, so lambda becomes now h by mv. This is your final formula. Okay, so now what is the de Broglie's wave equation finally? Wavelength is equals to h by mv. So you just remember this. Okay, what is that? Once again, lambda equals to h by mv. So now what I am saying, this de Broglie wave equation is applicable for microscopic particles only. For what? It means very small particles only, not applicable for the particles like if you take a cricket ball, we cannot use this de Broglie wave equation. Or if I take only electron, electron is microscopic particle only, no? Yes, for that it is applicable. So now let us take one example by considering cricket ball and one electron. Okay, I want to find the wavelength. What I want to find? Wavelength of a cricket ball. Approximately mass, how much it will be? Some 100 grams cricket ball. Wavelength of a cricket ball of mass 100 grams and moving with velocity let us take 20 meter per second. What is the velocity of that ball now? 20 meter per second. Then what we need to calculate? So what is the formula to use? Lambda equals to h by mv. So what is h? 6.6 into joules per second. Next, what about mass? See, joules here it is SI unit. So See, in the comment box someone is asking it's not a chemical bonding. See, you just hold for next 30 minutes, later I will start chemical bonding, okay, because few topics are remaining here, okay, yeah. And next, what about mass? 100 gram. See, joule means SI unit, right? So it should be written as kg meter square per second square. What is that? Kg meter square. So it is an SI unit now. So other things also should be mentioned in SI units. See, 100 grams means how many kgs? 0.1 kg. 100 grams now. So I can put 10 power minus 3 kg. So K means what? Kilo means what? Thousand should multiply, should I divide with 1000 so that it will be 1. Okay, that is what I am doing. Okay, see, multiply these two numbers, what happens? 100 by 1000, 0.1, that is what I am making here. Next, multiplied with velocity, 20 meter per second. Okay, so in the place of joules, if I substitute that units, see, second inverse square, and these things cancel. Okay, done. Okay, next one, here 0.1 into 20, 2 is there, so this becomes 3.3. So finally we got 3.3 into 10 power minus 34 meters. So this will be 3.3 into 10 power minus 24, huh? Wait, I will tell you. Minus 24 angstroms I am writing. See, what are the units here? Kg, meter square, second, power minus 2 is there. See, here multiplying with what? Joule into second now. Multiply with second. And also you are dividing with what? Second inverse. See, second inverse. Now you check. Cancel? Huh. Now, what is your final answer? 3.3 into 10 power minus 24 angstroms you got. See, angstrom means we know it's a very small quantity. With that small quantity, again you are multiplying with 10 power minus 24. So 10 power minus 24 is a big number or very small number? Very, very small number now? Yeah. So we can't even measure. So we can't even measure means the wavelength, if you try to measure for this cricket ball, the value is almost negligible, that won't even considerable. So that's why de Broglie wave equation won't applicable for macroscopic particles like large particles, only for microscopic. So if you want, we'll take one microscopic particle like electron we'll take. Okay, now tell me, like wavelength, this is first question. Second one, lambda of a electron in first Bohr orbit of hydrogen atom. What is that? First Bohr orbit of hydrogen atom. So now tell me, how can we find this? Lambda means h by mv. Like what about h? 6.6 into 10 power minus 34 joule second. Okay. Next one here, what about mass of electron? What is the mass of electron? 9.1 into 10 power minus 31 kg. Next, what about velocity of electron here? I need V value now. How can we get that? You just now studied that formulas. Velocity of electron revolving in the Bohr orbit. What is that formula? Velocity of electron, yeah, tell me. 2.18 into 10 power 6 Z by N. What is a Z? Atomic number, hydrogen. So it is 1 by first Bohr orbit. This is also 1. So finally what you going to get here? Meter per second. So this is your thing here. Take that 9.1 into 10 power 6 kg. Sorry. 10 power, how much mass ma? Minus 31 kg into, what is the velocity of electron we got? 6 meter per second. Okay. So now if you try to simplify this, what is your answer? See, if you simplify this, see, this is minus 31, this is minus 10 power 3. Okay. Then next, if you bring this above side, what happens? Denominator plus 6, numerator minus 6. Minus 6 minus 3? Minus 9. See, joules, this all if you cancel, you are going to get in meters. Okay. Next, what are the values we have here? 6.6 by 9.1 into 2.18. Okay. So if you try to write this as 66 by 9.1 into 2.18 meters. So 10 power minus 10 meters, how many angstroms? 1 angstroms. So your answer is in angstroms. So if you simplify this, around you are going to get 3.3. How much? So 3.3 into 10 power minus 10 meters. So I can write this as 3.3 angstroms. Right now? See, 3.3 angstroms, it's a very small quantity, but it is a measurable and considerable quantity. Yes or no? So here this can be considerable, but this one 3.3 into 10 power minus 24. So it's a very small quantity, you know. So even if you compare with that, it is a negligible one. So that's why de Broglie wave equation applicable only for microscopic particles. Done with this? Yeah. Even to like how to use a formula also, you got the thing, right? Next one. Let's move forward. Yeah. Compulsory. Next one, what is this? Heisenberg's uncertainty principle. So what this hypothesis says, that you cannot find exact position and exact momentum of an electron. Okay, simultaneously we cannot find. If you try to find, there will be some error. What is that? If you try to find, there will be some error in your measurement. Okay, let us say if you are trying to find its position. Okay, some error will be seen now. What I am saying, he is saying there will be some error. So how much error he is saying? Let us say, see, if x is a position, so when you are finding the position, there will be some error. That error is represented with delta x. So del x represents what? Error in position. Similarly, when you try to find its momentum, what is that? Momentum. So there will be some error. That error will be indicated with delta p. So error in momentum. So now the the product of these two, delta x into delta p, will be either greater than or equal to h by 4 pi. So if you take this value, if you simplify this, you are going to get some fixed value now. So at least that much error will be found if you try to find the exact position or momentum of electron. What he is saying? If you try to find an electron, there will be some error. That error will be either greater or equals to this value. Okay, are you able to understand little bit at least? What he is saying, since electron is a very small particle, it is revolving around the nucleus with very fast. If you try to find its exact position, you can't find it exactly. If you try, there will be some error. That error is how much? H by 4 or greater than this. Okay, so while doing the numericals, you just make it equals to h by 4 pi and you can simplify it. Okay, right. So now how can you write this? Delta x into delta p. While doing the numericals, you can take it like this. Okay, yeah. So now what do we mean by momentum p? Mass into m into v now. So here mass, for example, I am saying mass of electron will be fixed now, but mass of like velocity of electron changes. If it is a first orbit, some velocity. In second orbit, some other velocity. It depends on z by n values now. So here mass will be constant, but velocity changes. So wherever I have del p, I can write m into del v also. So I am writing here del x into m del v h by 4 pi. Okay, so these are the two formulas you should remember here. Okay, so write this. Okay, I will show you one question, then you will feel little more clear with this. I'm okay. Okay, the next one here. Okay, done with this? Okay. Okay, look at this question. Once read the question once. Uncertainty in position. It means, what is that uncertainty means? Uncertainty means what? Error. Error in what? So that is indicated with delta x. Next, uncertainty in that should be represented with so you should be writing like this. So error in position and error in velocity of a particle are, so position error is this much and velocity error is this much. Then find the mass of that particle. So what is the formula to use? Delta x into m delta v, that second one we have written now, is equals h by 4 pi. That's it. So what do we know here h means? 6.6 into 10 power minus 34. Okay, here 4 pi as it is. Next, what about this? Position error is how much? 10 power minus 10. Mass we need to find. Velocity error is how much? 6.626 by pi into 10 power minus 24. Okay, see this 6.626, this side also, this is, if I want to write fully, it will be also 6.626 only. So this number got cancelled. For pi also removed. Okay, 10 power minus 24, 10 power minus 34 means 10 power minus 10 means 10 power minus 34. So this number also removed. Finally, mass of electron, if I ask you, whatever that particle, 1 by 4. So 1 by 4 means it is in kg you will get. So it will be 0.25 kg. So which option is perfect here? So that's it. So are you got to know like how to use this formula? Yeah, that's it. Okay, yeah. Next, we will solve questions related to this HEUP again once after completing the session or evening study over times. Okay, now let's move forward for quantum numbers. What is it? Quantum numbers. So quantum numbers means here see, Bohr model consider what? Electron as a particle nature only. What is that? Electron is considered as a particle only. But when it comes to quantum model here, he consider both Heisenberg uncertainty principle and de Broglie wave equation. So from that they have got one equation that is called Schrödinger equation. What is that? Schrödinger's equation. Now I will tell you how to remember that Schrödinger equation. See, they won't ask you how they got these, all those things. See, you just take one del like this, del psi square plus 8 pi square m by h square. What I am saying? Del psi square plus 8 pi square m by h square E minus V psi equals to 0. What is that? E minus V. If you are seeing this, you might be feel scary, but you can at least remember like this. Del square psi, del square psi, what is this? Del square psi 8 pi square m by h square E minus V psi equals to 0. Okay, so this is what this Schrodinger equation means. Okay, what is that called? Schrodinger equation. So now, sir, why you put this del box here? You might be having that. See, this is nothing but you should write like a mathematical equation like this: dou square by dou x square, dou square by dou y square plus dou square by dou z square. This all they have used now. So I have simplified them as like this. This box indicate all this dou square by dou x square, all those things. Okay, you can remember it in this way. Okay, and one more equation, the same one can also be expressed in this term. In the previous NEET exam they have asked once this equation like this. Okay, so this H is called Hamiltonian operator. What is that? H is called Hamiltonian operator. Here E is energy. Okay, just remember like that. So E means what I told you? E, energy. Here also E means energy only. So here it is given. So V means what? Potential energy. This is total energy, this is total potential energy. Okay, so now next from this Schrodinger equation we don't want to solve anything, but upon simplifying this equation, this will be in the higher classes, upon simplifying this you are going to get quantum numbers. What you are going to get? What are the quantum numbers we have? Like spin quantum number, angular quantum number, magnetic quantum number. What is that? Spin quantum. So out of this only principal quantum number, angular quantum number, azimuthal quantum number comes from Schrodinger equation. What are the three quantum numbers comes? So those three comes from where? From Schrodinger equation. But another one is a spin quantum number, last one, that is added from the outside, but the first three comes from this Schrodinger equation. Okay, sir, exactly how they comes, that solving all those things are not required. See, for example, electron is somewhere at this point. See, this simplification all is not required, not in your syllabus also. So from this point to here, from the, let us say, nucleus to here, so some distance r is there now, from something like radius we are saying. So now this is size from like radius you are saying now, so that is called a radial part. What is that? Radial part. So from that radial part we are going to get about principal quantum number n. What we are going to get? Principal quantum number n, and also angular quantum number L. And one more thing, see, electron is revolving around the nucleus with some angle like this. So that is called angular part, theta part. What is that? From this theta part, angular part, you are going to get L and ML. What is this? L means angular quantum number, ML means magnetic quantum number. So from radial part you are going to get NL, from angular part you are going to get LML. Okay, that's it. Okay, how they are getting, all those are not required, but you just remember these lines. From radial part, what you are going to get? NL. Theta part? That's it. Okay. See, now I will tell you, before starting quantum numbers, I will tell you something like this. See, there is something called shell. What is that? Shell. And subshell. What is that? Subshell. Next, orbital. What is that? Orbital. Next, electron. Something like a person comes to your like here is a person like asking your address, like your district, your mandal, your village, your street, your house, and your name. Like this we have now. Similar to that, for saying electron address, we have these quantum numbers. What is the use of quantum numbers? It will say the address of an electron. What they will say is? So first one is what? Principal quantum number. Now we are indicating with symbol n. With what? N. So that n says about shell. Okay. The next one is what? Second one? That one. Angular quantum number L, indicated with symbol L. So that says about subshell. Okay. So shell numbers means 1, 2, 3, 4 we are writing now. Subshell means like you are writing SPDF, S subshell, P subshell, like 1s2, 2s2 you are writing now. So those comes under subshell. Okay. And in this subshell, like you are saying S orbitals are 1, P orbitals are 3, D orbitals are 5, you are writing like that now. So that says, that comes from magnetic quantum number ml. Okay. So now that is what? The number of orbitals in a subshell. So shell contains what? Subshell contains what? Orbital contains what? See, something like address we are going to get for the electron. Yes or no? So shell, subshell, orbital, electron. Okay, this electron has half spin plus half spin and minus half spin, that comes from spin quantum number. That's it. Okay, so now once again you don't get confused with these numbers now. So there are how many quantum numbers? We have 4. First one is N, L, ML, MS. So this is this required to define, these 4 set of quantum numbers are required to define an electron completely. Okay, the first one, who given that? Niels Bohr. So what it tells about? It tells about the energy of the shell or radius, size of the shell. What it says? What is the radius formula we got? 0.529 n square by z. See, if n value increases, if shell number increases, radius also increasing. So size and energy formula also has n. So size and energy given from where? Given from where? Principal quantum number. So as n values increases, size increases, energy also increases. Okay. So that is comes from this Niels Bohr thing. Next one, what I told you, energy of electron we can say. Okay. So now there are 2 systems. One is single electron system. What is that? Give some example for single electron systems. Hydrogen atom. Next, helium, ion. Next, lithium plus 2. Okay. So now, beryllium plus 3. So now how do you write their electronic configuration, like 1s, 2s, 2p, like this you are writing. Now I am asking you to say their energy order. Which orbital is higher energy, which is lower energy? Listen, this very important question it is. Which one is having lower energy? 2s, 2p, 3s, 3p, 3d. Yeah, tell me now. What is the energy order I am asking? See, whenever there is single electron system, what I am saying? Whenever there is single electron system, energy order depends only on, n value. Depends on what? So what is the n value here we have? So lower energy, lower n value, lower energy. So now here what is the n value? What is the n value here? So it means both of them have equal energy. Now between these two, like this, between these two equal, between these two equal. So whenever there is a single electron system, what will be the order? It depends only on now when it comes to multi-electron system means what? Like instead of saying helium ion, nucleus ion, I can write it as helium atom, lithium atom, beryllium atom, carbon atom. So here what is the electronic configuration you are writing? Like again same 1s, 2s, 2p, 3s, 3p, like this we are writing now. Now if I ask you the energy order, how can you answer this? Single electron system means energy depends only on when this is a multi-electron system, what is this? Multi-electron system. You should take N and also L. What is that? N and L. So N comes from principal quantum number, L comes from angular quantum number. So for a given N value, what I am saying, for a given N value, L should be always lies from 0 to n minus 1. From where to where? For a given n value, L will be always from 0 to n minus 1. It means if n equals to 4, what are the L values possible here? It can be 0, 1, 2, 3, that's it. Can I write 4? No, it should be always at least one number less than that. Okay, so now if L value is 0, what I am saying, L is equals to 0, you should say it as S subshell. What is that subshell? If L equals to 1, you should say it as L equals to 2, D subshell. L equals to 3. So like that, L equals to 4, it can be G. Okay, S, P, D, F, like that it goes on. Okay, so you need to remember like this. So whenever I am saying multi-electron system, energy depends on what? Both N and L values. So you should take sum of this N plus L value. See here, what is its N value? Ikkada ఎంత ఉందమ్మా 1. S ki L value is how much? For S 0. For this one you tell me 2 plus 0. For this one you tell me 2 plus 1. For this one you tell me 3 plus. For this one, so which is highest N plus L value? 3 plus 1. So this is higher in energy. Between these two, this is 3, this is also 3. So you should not write they are equal. Why they are not equal? Because when N plus L values are same, what I am saying, whenever N plus L values are same, now you need to look for N value. There are two things ma. First you need to look for N plus L. If N plus L values are same, then look at the N value only. If greater the N, greater is the energy. So here N plus L values are 3 and 3. So who is having greater N value? So that will be having higher energy. Between these two, 2p. This one, between these two, 2s, like this. So this is the story when it is for single electron system, only N value you need to check. Okay, is this clear everyone? Yeah, we will come back to this while doing the questions. Okay, so now for a given shell, number of electrons possible. So what I am saying, for a given shell, number of electrons possible are, how can you find this? See, for example, I am saying at first energy level, n equals to 1 level, how many electrons you can fill? For n equals to 2, how many electrons you can fill? So for this, I will give you one simple formula. You just take 2n square formula. What is that? 2n square. So 2n square means what? See, if n equals to 1, n equals to 1 I am saying now. So 2 into 1 square. Like how many electrons you can fill? Only maximum of 2 electrons at shell number 1. At shell number 2, 2 into 2 square, 8 electrons. So that's why when you are writing 1s, how many you are writing? 1s 2. But when you are writing second level, 2s 2p. How many you are writing in 2s? 2. 2p? Maximum 6. So total number is how much? So that's why it is 8. Okay. Now tell me n equals to 3 means? 18. So what are those 18 electrons you tell me? 3s, 2, 3p, 6, 3d, 10. So total how much? You got the concept what I am saying? Yeah. So n equals to 4 means 2n squared, 16 into 2, 32, like that. Okay, that's it. Next. What is next? Like azimuthal quantum number. So our magnetic quantum number. So what this says? Okay, azimuthal quantum number is over already. So it is indicated with symbol L. So this is after n I am saying L. So for a given n, how this L values will be? 0 to n minus 1. If L value is 0, what is that our subshell number? Name S. if it is 1, like that we already discussed. Okay. So these are the L values and the designation of subshells. Okay. So what we are discussing, like s orbital in spherical in shape we will discuss now. So it will be looking like this, something like this. P orbital means dumbbell. So what actually it is saying, see, it is something like dot 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 like this now. If you observe it properly, it means this is a region where you can able to find the electron. What is that? This is the region where you can able to find the electron. So when it is s orbital, it is a spherical in shape. It means this is a region where you can able to find the electron. So dumbbell, like here d orbital means this is the region that you can able to find the electron. So what do we mean by orbital now? The probability of finding an electron is maximum. So when I say s orbital, so this is a region where the electron probability is maximum. That's why we are saying s orbital has spherical in shape. Okay, like p different shape like that. Okay, the next one, magnetic quantum number. See, for a given n value, what are the L values possible you told? 0 to n minus 1. Now for a given L value, ML values will be minus L2 plus L. Okay, for example, n equals to 3 I am saying. What are the L values possible? L values, L 0, 1, 2, that's it. Now what are the ML values possible? If I ask that L equals to 2, L equals to 2, ML values will be minus 2, minus 1, 0, 1, 2. Yeah, if L equals to 0, ML will be 0. If L equals to 1, ML will be minus 1, 0, plus 1. So now you should need to know that for s orbital, what is the L value told? 0. So that's why we are writing L equals to 1, 1 means ML value will be, like L equals to 0 means s orbital you are saying now, ML value also 0. So it means you are writing only one box now. What is that one box represents? It has only, s subshell contains only one orbital. So when ML like L value equals to 1 you are saying, for which orbital which subshell you are saying this is? P. So what are the ML values you are saying? Minus L, minus 1, 0, plus 1. So it means how many boxes you are going to get? 3 boxes. So P orbital has 3 boxes you are writing now. So if I say L equals to 2, what is this subshell? D subshell. So what are the ML values you are writing? Minus 2, minus 1, 0, plus 1, plus 2. So how many numbers you got? So that's why you are writing 5 boxes, 5 orbitals. Okay, it means in D subshell how many orbitals are there? In D subshell how many orbitals are there? Like 5 orbitals. These are the 5 orbitals. Okay, in P subshell how many orbitals are there? Px, Py, Pz are minus 1, 0, plus 1. Okay, and S subshell how many orbitals are there? 1. Okay, similarly for F, how much L value? 3. So minus 3 to plus 3, how many you will get? 7. So 7 boxes you are writing for that. Okay, like that. Okay, next one, spin quantum number. So like they say that electron has 2 possible spins, clockwise and anti-clockwise. If you are writing clockwise with plus sign, anti-clockwise with minus, or vice versa also you can represent. That's it. Okay. So now with using these 4 things, we need to fill our electrons in the atoms. Okay. So while filling the electrons in the orbitals, we should follow 3 rules. One is Hofbauer principle, next Pauli's, next Hund's rule. So what this Hofbauer principle says? We need to follow energy orders. What we need to follow? Energy orders. So that I told you now, n plus L value we should consider. See, carbon atom is single electron system or multi electron system? How many electrons are there? 6 means it is a multi-electron system only, na? Yeah. So for that, which rule we should follow? N plus L rule. So N plus L rule if you follow, see 1s orbital we have, 2s, 2p, 3s, 3p, 3d, like this we have. So what to consider? N plus L value. So fill the electrons in lower energy first. Where do we need to fill? Lower energy first, then higher energies. This is what Hauve principle says. So it means I have 1s, 2s, 2p I have. So how many electrons I can fill in 1s? One orbital can accommodate maximum of 2 electrons we know, with plus half, minus half. Like that I am filling here 2. Between these two, who is lower energy? 2s. How we are deciding its energy? N value is 2, L value is how much? 0. 2 plus 0. For this 2p, N value is 2, L value is 1. So it is 3. So which is having greater N plus L value? 2p. So higher energy for it. So where do we need to fill first electron? So here. How many we should fill? Out of 6, 2 over, remaining 2 here. Next, still 2 is there. I can fill here the 2. Like that we are writing the electronic configuration. So this diagram help us to follow Hauve principle. That's it. Next, Pauli's exclusion principle, what it says? See, an orbital can accommodate maximum of 2 electrons. How many? Now my question is, this is a previous year question. D orbital can accommodate how many electrons? D orbital accommodate how many electrons? Once again, F orbital accommodate how many electrons? P orbital accommodates how many electrons? All answers are wrong. Orbital accommodate how many electrons? This is your answer. Just common sense. Right now, orbital means how many electrons? Okay, double ఎన్ని electrons fill చేస్తాం? That is what they are asking. Orbital accommodate how many electrons? If I ask you, P subshell accommodate how many electrons? This is your answer. P subshell means 6. P orbital means 2. Is this clear? D orbital means 2. D subshell means 10. Do you got the difference here? Yeah. See, I just now told you, for hydrogen atom, like single electron system, what could be the energy order? Like this. It depends only on what? N value. So that's where it is mentioned like this. Okay? See, the total possible values of M for a given subshell. See, L value is 1 ma. How many subshells are possible I am asking? L value equals to 1 means which subshell it is? P. In this P subshell, number of orbitals. Number of orbitals. How can we do this? Number of orbitals equals to 2L plus 1. What is that? 2 into plus 1 like this. 3 we got. Like Px, Py, Pz you are writing. So L equals to 4. 9. So what is that orbital? Subshell? It is a hypothetical G we can say. Okay. So L equals to 3. 7. What is that subshell? F subshell. That's it. Let's do these questions fast. The quantum numbers for an electron in the outermost orbital of potassium. Potassium means, atomic number 19, the last electron goes to which level? 4s1. So 4s1, for that 1 electron they are asking. N equals to 4. L equals to S orbital, L value is how much? 0. ML will be, that is also 0. MS will be plus half or minus half depending on the options you take. B, that's it. Next. This questions you tell me fast. Compare the energies of the following set of quantum numbers for multi-electron system. See, in the question, if they mention single electron system, then only consider N value. If they won't mention any system or they particularly mention multi-electron system, follow N plus L rule. That rule is called Bohr-Bury rule. What is that? N plus L rule is called Bohr-Bury rule. Okay, now tell me, for this multi-electron system, tell me N plus L values given, check and tell me. Which is having lowest energy? Hare, how much ma this one? Check like that. 5, 6, 4, 5, 4. So least energy is for E. So let's go with the options. They are asking these options to be arranged in the increasing order or decreasing order. Tell me which is perfect answer. Highest energy is for which one ma? B. Which option is having B? Only first option is having B. It means definitely first option only correct. That's it now. You got everyone how to do that? Okay, reverse order B is okay. Here also it is there. Okay. Let's check. Okay. So here we have B. Next after that 5. Okay, this is incorrect. This is correct. Next after this one either A or D. What to check? N values are same. N plus L value same. Check for N. So greater N here. A here. This is A here. Next after this D, definitely D. So this is incorrect. B na? D. That's it. This one. Okay. What we checked here? Inka raleda? We'll see. Forgot about options ma. Tell me from here which is highest? B. Next after this A. Next E. Next C. Now match the one. Which one? Whatever it is you take that. But you got it now? What we are doing? Yeah. Next. Maximum number of electrons that can be accommodated in a shell with N equals to 4. What I told you the formula? 2n square. Perfect. So how much? Now I am adding two formulas here. Number of orbitals in a shell is equals to n square. What is that? Number in each orbital, how many electrons we can fill? 2. So it means 2 into n square gives number of electrons in a shell. Number of electrons in a shell. How much? 2n square. 2, 16, 32. So which one? B. Next one, arrange the following orbitals in the increasing order. Decreasing order. Tell me. What to do? Just n plus L. Check here. This is 3. This is 4. This is 4. This is. So which is highest? D. After D? After D? B. Next C. A. D, B, C, A, B. Perfect everyone? Everyone got this or not? Yes. Now I am asking a question. For the same options, up to here it is clear now? No confusion everyone. Okay. For the same options I am asking, arrange the following in the decreasing order of energy for single electronic system or hydrogen like species. So what is your answer? For single electrons or hydrogen hydrogen like species. What to check here? Hydrogen like species means only n value. So check and tell me. B greater, the next A equals to C equals to D. Like this you should answer. For which one? So got this? Yeah. Quantum numbers I think almost done. Yeah. Few more questions are there, but this is the last question. Remaining we will do in the study hour. Yeah. Do this. 6, first one is 6, second one is 5, 4, 5. So first one will be highest only in these two options. Next one 5, 5, 3, 1, 3, 1, 3. So second option is perfect. Got it, everyone? Yes. Last, these two questions last. I don't want to extend anymore. Maximum probability, in which case? S orbital case. When you go for p orbital, it is something like this, dumbbell shape. If this is the nucleus, from nucleus, if I move away, I am going to get a bigger lobe like this. Size is like this now. It means if I go away from the nucleus, I mean little far from the nucleus, we are getting big side, like lobe side. It means as I move away from the nucleus, probability of finding electron is increasing. But at the nucleus, 0, like minimum. Yes or no? Yeah. So now look at this. If I write like this is like radius I am saying. This side is some wave function I am saying. Okay. So for s orbital, for what I am saying? At the origin, at almost close to the nucleus, what is the probability of finding electron? Maximum. So I hope you know that when you are drawing the graphs, maxima means amplitude should be bigger. Like this is maxima. If it is touching it here or touching this x-axis means that is 0. Probability of finding electron here is 0. So that point is called a nodal point. What is that? Nodal point. So now if I write like this, so this center point is called what? Nodal point. Okay. So now for s orbital, it is maximum na, near to the nucleus. So your graph should start from maxima and should go like this. Okay. Now it is going like this. So this is the one which is having started from here. So this indicates s orbital. What is that? It indicates? Sir, this is also starting from maxima, na? Yes, this is also indicates? This is also starting from maxima, so this is also? Sir, this is starting from origin, so it cannot be S. It can be now P or D orbital also looks like this, it can be D, or F orbital also look like this, it can be F. Okay, but it cannot be S. Up to here it is clear. Okay, next one more thing, how many times it is touching the nodal place, I mean x-axis? You are thinking about this last point now. See, when you are writing, the starting point and ending point, don't count. In middle, how many times it is touching? 0 times, right? This one? 1. So it has number of nodes equals to 1 node. For this one, 1, 2. Number of nodes equals to 2. For this one, 0 nodes. Number of nodes equals to 0. Okay, up to here it is clear. Now I will be giving you one formula just to see. There is something called radial nodes and another one is called angular nodes. So radial nodes equals to n minus L minus 1. What is that? Angular nodes equals to L. Now total nodes equals to these two. Radial nodes plus angular nodes. So this is n minus L minus 1. This is L. So total it will be n minus 1. So total nodes equals to how much? See, we are talking about radius now. So here it should be considered as radial nodes. What is that? So this orbital is s orbital, you are saying this is also s orbital. But which orbital exactly? 1s or 2s or 3s? Which orbital it is? How do we get to know? Finding its number of nodes. How many nodes we got here? 0. So try to substitute in this formula. Radial nodes equals to, let us say, radial nodes how many we got ma? 0. So this is 0 equals to n minus s orbital you are saying na? For L value is how much for s orbital? 0 minus 1. So L equals to, n equals to 1. It means n equals to 1 and you are saying this is s. So it is 1s orbital graph. Similarly you tell me for this. How many times it is touching? 1. So radial nodes are 1. If radial nodes is 1, Radial nodes are 1 means 1 is equals to n. N value we need to find. S orbital only now. L value is how much? 0 minus 1. So n equals to minus 1, send that side. N equals to 2. So it becomes 2s. Are you getting what I am saying? Okay. Next, you do it for this. Easily you can say this is 3s. Okay. It can be now 2p or 3p or 3d like that. Now exactly sir, how can we do that sir means, see, like this I am writing ma. See, the peak will be like this peak of the curve is like straight, but this is expanding, this is still more expanding. It means for p orbital the peak will be sharp. For d orbital it will be broad. For d orbital it will be more broad. What I am saying, this peak is there now, like this. The peak will be like sharp for p. As we go from p to f, the broadness increases. Like this I am writing ma. This is sharp or not? Yes. If I ask you which is for p, which is for d, if I ask, this is p, this is for d, like this, that's it. Okay. Hope we have done enough amount of questions on structure of atom. You just practice from your side and ask me if you have any doubts. Okay, next we will discuss about chemical bonding. See, one of the most easiest topic of complete syllabus I can say, and most weightage topic also. Okay, and this is an independent chapter. Like it don't depend on previous question topics also. Just follow me, I will tell you. Okay. The first one here is while like basics of chemistry I discussed. What are those? Covalent bond, ionic bond, coordinate covalent bond, metallic bond, next hydrogen bond, all this we discussed. Okay, so now next one, Lewis dot structure we discussed now. Lewis dot structure means what? Electrons are considered to be dots, we are writing them around the atom. Okay, next Fazan's rules, yeah, from here you can expect a question, and also on formal charge. Okay, let's start with the topic. So now why the chemical bond formation takes place? Okay. So what is the reason for chemical bond formation? So we know by chemical reactions that molecules may attain stability. Okay, so now that can be possible. See, that can be possible, like why chemical bond formation takes place. It means to attain stability. Okay, so now this attaining stability may happens by losing the electrons or by gaining the electron. Finally what they will get? They will get the inert gas electronic configuration. Okay, so now this process can be takes place in three ways we discussed. What are the ways? By transfer of electrons, by sharing, or by donation of pair of electrons. So where we will see this transfer of electrons? Complete transfer, it means completely you are giving the electrons. Ionic bond, like metals will generally transfer the electron to the non-metals, like sodium transfer electron to the chlorine and it becomes sodium ion, chloride ion. So between these positively charged and negatively charged species, electrostatic will be there, that results to ionic bond formation. Next, this mutual sharing, when it happens, tell me? Covalent bond formation cases. So like if two homovalent atoms like this, monovalent atoms are there, so they are mutually sharing to form H2 like this. Okay, now this one, donation of lone pair electrons, in which case we discussed that one, coordinate covalent bond, like ammonia we have taken and BCl3 we have taken here. So it has only 6 electrons, ammonia has how many electrons? 8. So from that these lone pairs are given here and making a NH3 BCl3. See, for bond formation both electrons are coming from ammonia only now, so that resulting bond is called coordinate covalent bond or dative bond. Okay, next one is dot like this one, Lewis dot structure we discussed. Okay, I think it is not required again here. Okay, now tell me which of these are having expanded octet? Tell me which is having expanded octet? PCl5. So how to say that? Octet means how many? 8. Octet means 8. If it is less than 8, you should say incomplete. If it is greater than that, expanded. So now here if you say BF3, boron, what is the group number? 13. How many valence electrons it has now? Like 1s2, 2s2, 2p, 1. It means 3 valence electrons it has. How many surrounding atoms here it has? So 1, 2, 3. Now how many electrons it has in the molecule? 3 bonds means 6 electrons. So 1 vacant orbital is there. So less than 8 now, you can say it as incomplete octet. Next, what about PCl5? Phosphorus, how many valence electrons? Like 3s2, 3p, 3. How many valence electrons we got here? 5 valence electrons are there. So put 5 dots. Okay, how many chlorines are there? 5. So each chlorine 1 valence electron with this. 7 valence electrons are there with the halogens. Like this. Like this. So now how many electrons are there in the phosphorus central atom here? 5 bonds mean 5 to the 10. So can I say it is more than 8? So expanded octet. So option 2 is your perfect for this. Now in the case of hydrogen, you will be having what configuration I told you? Duplet. Okay, that's it. CCl4 you have octet configuration, that's it. Next one. See, there is a question like this. What the question says, 7C, the correct order of CO bond length in CO, CO3 2 minus and CO2. So what is this CO means? Carbon monoxide. It will be having like this. Next one is what? Carbonate ion, like this. Next one, this one, carbon dioxide means it will be like this. Okay. So now here, between two atoms, if one single bond is there, it will be like this. If two bonds are there means, see atoms are coming close or moving forward? Coming close. If one more bond is also formed, they come little more closer. So as number of bonds increases, bond length decreases. So bond order and bond length, how they are related? Inversely proportional. Bond order means number of bonds between two atoms. So more the number of bonds, lower is the bond length. So I can say bond order and bond length are inversely related. Okay, like this. See, between two atoms, how many bonds are there here? 3. So it has 3 bond order means, but here if I say CO, how many bonds you are seeing? Here also between C and O, but 1 C and O, 2 bonds. Here it is 3 bonds. Now what about this one? Here, you just listen. There is a concept called a resonance. What I am saying? Resonance. So resonance is possible when pi bond, sigma bond and some charge are in alternate position. What I am saying? Pi bond, sigma bond, charge should be like an alternate position. See, pi, sigma, charge. They are alternate or not? Yeah. So it will shift here. The next this pi bond goes to the oxygen side. So what you are going to get here? C. This single bond is now becoming double bond. Next this double bond becoming O minus and this is O minus. Like this same story will also possible with this negative charge. Okay. So this concept is called what? Resonance. All surrounding atoms same only now. So for all the surrounding atom resonance is possible now. If I write double bond between only this carbon and oxygen, you are seeing like a double 2 bonds. But due to this conjugation, the double bond character is spreading through these 3 atoms. It means one double bond is shared by how many atoms? 3. Like this one and this one. 3 atoms it is sharing. So does it has pure double bond character or partial? Partial. So that I can represent it like this. C O O O like this. 1 place some number. See, one pi bond is shared by how many numbers? How many atoms? 3. So one sigma bond completely and one pi bond is shared by 3. So 1 plus 1 by 3 I can say. So what is the bond order here I can say? How much this is? 1 by 3 means 1.33 only now. If you add this, how much you will get? Okay, 4 by 3. Simplify it. 1.33. 1.33 only now? Yeah. So here the bond order is how much in this case? In this case is how much? In this case how much? So where do we have more bond order? First case more bond order. So it will be having least bond length. So now which is our perfect answer here? Tell me. Least bond length. Next least bond length here also. Next highest bond order is for this. So least bond length. After this CO2. So here. So see. Do you got how we are deciding this? Bond length, bond order, based on that we are doing this kind of questions. Okay. Next one. There is something called formal charge. What is that? So formal charge means, formal charge means how can you do is take number of valence electrons, what I am saying, number of valence electrons minus number of non-bonding electrons plus half into number of bonding electrons. Okay, for example, here, so you tell me out of these three which atom I should calculate. Let us do it for 1, number which is indicated with 1. So it means I am doing for which one? This terminal oxygen. What is the formal charge of first oxygen I am doing? So how many valence electrons for oxygen atom? How many are there? 6. Okay. Minus, now in the structure, how many non-bonding electrons are there? 4. Paina 2 dots, kinda 2 dots. So 4 electrons. 4 plus half into number of bonding electrons are how many? 2. Between these two, how many bonds are there? 2. 2 bonds are there. Bonding electrons means? Okay, bond lo enni electrons untayi amma? 2 electrons. How many bonds are there? So 2 2s are 4. So I should take here 4. So try to do this. 6 minus 6. So what is the formal charge on first oxygen? 0. Okay. Similarly, will you do it for the next one? You do it for last oxygen. Otherwise, this oxygen 3. Formal charge for 3. How can you do that? Tell me first. Oxygen only now? How many valence electrons? This one 3, 6 minus number of non-bonding electrons you are seeing? 6 plus bonding electrons 2. How much? 6 minus 6 plus 1? How much? So on the terminal oxygen, what is the charge you should include here on this? Minus 1. So this will be minus 1, this will be 0, no charge inclusion, and on middle one you just try it, you will get it as 0. Okay, if you solve it, you will get 0. Okay, so like this, you have questions in the exam, final exam like this. See, they will give the question and they will mention the formal charges like on 1, 2, 3. So what is the formula to calculate that? So number of valency electrons minus number of non-bonding electrons plus half into number of bonding electrons. That's it. Okay. So you can try this. Already we did. You will get one answer in this. So what is your answer? Tell me. 0, 0, minus 1. Definitely B. Okay. See. From the same thing, they are making this kind of questions. See, this is a question they have made. How can you solve this? Formal charge QF is equals to what to use? Number of valency electrons on the central atom minus number of non-bonding electrons indicated with symbol U. Next. Half plus half bonding electrons. Instead of saying bonding electrons, in one bond 2 electrons are there. Okay, instead of saying like bonding electrons, can I say this as number of bonds itself? That's it. So you can see where do we have this kind of formula? That's it. That is your answer. Okay, you got what we are doing? Yeah, fine. Next. Yeah, next one is ionic bond. So how ionic bond is formed? By transfer of electrons. Now what are the factors affecting it? One is ionization energy, another one is electron affinity, lattice energy. Okay, so lower the ionization energy for metal and greater the electron affinity for non-metal, the resulting compound will be more ionic. What I am saying? Lower the sodium chloride, cesium chloride. What are the two things given? Sodium chloride and cesium chloride. So out of these two, which is more ionic, I am asking. Out of these two compounds, both of them are ionic, we know, but which is more ionic? Cesium chloride. How you are answering this? It has a lower ionization, lower, down the group what happens to ionization energy? So lower ionization energy for metals, it will be resulting to be form more ionic compound. Okay, now see, NaF, okay, you just stick up to here. So what I am writing, low ionization energy and more electron affinity results to give you greater ionic character. Okay, what are the two factors to consider? Ionization energy, electron affinity. Electron affinity for non-metal, ionization energy for metal. Okay, next one. Lattice energy is there, na? So more ionic compound, more is the lattice energy. This is the amount of energy released when a lattice is formed. It means, see, sodium chloride is a crystal, na? Ionic compound which exists in crystal form. So that crystal form is nothing but they will form some lattice structures. That crystal formation is there, na? So during that formation, it will releases energy. So more amount of energy released, more is the ionic character it has, I can say. That is what more lattice energy it has, I can say. Okay, so lattice energy is directly proportional to Q1 Q2 by R. It means greater the charges, like Coulomb's law you have now, like that. Greater the charges, greater is the lattice energy it has. Okay. Next. Okay. So now in ionic compounds, what I am saying? In ionic compounds, see, NaCl is an ionic compound, you are saying. Next, NaBr is also ionic compound. Both of them are ionic compounds, but which is having more ionic nature out of these two? This is the question. Both of them are ionic compounds, but which is having more ionic nature out of these two, I am asking. So to explain this, we have something called Fazan's rules. What is that? So now, what is the use of Fazan's rules? Tell me. Fazan's rules. What is this Fazan's rule explains? Covalent character in ionic compounds. What it will do? It explains covalent character in ionic compound. So for every ionic compound there is some covalent nature. For every ionic compound there is some covalent nature. It means there is no compound 100% ionic. What I am saying? There is no compound 100% ionic. For every ionic compound there is some covalent nature. That is explained from. So what he says is, in an ionic compound we have a cation and we have a anion. So cation, anion. Okay. So just 5 rules are there, follow them. So cation should be small. What I am saying? Cation should be small. Should have more positive charge. What it should have? More positive charge. Definitely cation means positive charge, but it should be more. Okay. Anion should be large. This one charge, more negative charge. If this is followed, then that compound will be having more covalent character. What they have? More covalent character. So first example here I will take is the one which I have written previously. NaCl, next MgCl2. Okay. So look at this, ma. First of all, sodium, what is the charge here? +1. Next, magnesium means +2. Here also like chloride ion only, here also chloride ion. So we cannot answer with respect to anion, but we can give with respect to so which is having this size, smaller size or more positive charge? Magnesium more charge na, like isoelectronic species, so small size it has. Okay, so which is small size? Magnesium. So if it has a small size, cation should be small size or more positive charge, then that resulting compound will have more. So out of these two, which is more covalent? So this will be more covalent. Okay, the next one I am saying here NaCl, NaBr. Tell me for these two. Cation same, anion, chloride ion, bromide ion. So what to check here in case of anions? I told you negative charge, same negative charge. Now look at the size. Down the group, what happens to size? So greater size for anion, greater is the covalent. So NaBr will be now more covalent than this NaCl. Okay, right. So now what is the use of understanding covalent nature and ionic nature? See, ionic compounds have greater melting point and boiling points. What they have? Greater melting points and boiling points. Now based on greater melting point, boiling point and also solubility. What is it? Something like if you want to mix salt and also sugar, which will mix easily in the water? Salt. Like that, more ionic compound, more easily it will dissolve in the water. So based on that, ionic compound soluble, more soluble when I compare with the covalent. So if I give you these two compounds, which is more soluble in water, I am asking. So one which is having more covalent, more ionic nature will dissolve in the water easily. That's it now. So based on that, you can also give solubility order. So what is the applications of Poisson's rule here? It explains covalent character in ionic compounds. Again, with the help of that, we can give their melting point orders, boiling point orders, solubility orders. Okay? Can you answer me these two questions fast? Which of the following statement is true? FeCl2 is more covalent than FeCl3. Is that true or false? How can you answer? Charge of anions same. Look for cation. Here Fe plus 2, Fe plus 3. So more positive charge, more covalent nature for that compound. So Fe plus 3 is more covalent. Now Fe plus 3 is more covalent than Fe plus 2. This is correct only now? Next, both of them are equally covalent? No. Next, we cannot have any, no. Next, this one. Hydrates, calcium hydride, beryllium, barium hydrates are given. Ionic character they are asking. See, decide their covalent character using Poisson's rule, take opposite of it. That is your answer for ionic character means. So what to check? B. Cation should be small, or cation should have more positive charge. Next, with respect to anion, anion should be large and anion should have more negative charge. Okay. So if these four rules are followed, then that species will be having more covalent character. Now here you tell me, see these are alkali metals only, alkaline earth metals now, like beryllium plus 2, calcium plus 2, barium plus 2 is given. Okay. Now tell me down the group what happens to the sizes? Sizes increases. So this is large size cation, and this is small size cation. Hydrides means H minus only. Anion is same. You can answer with respect to cations. So which is small size cation here? Beryllium. So small size cation results to form more covalent compound. Yes or no? It has more covalent. More covalent means least ionic. Which is least ionic? Least ionic is this one. Next this one. Next this one. That is your answer. Okay, got this? Yeah. Next. Okay. See, the final exam you are going to see questions from this thing. What is this? Hybridization. Mostly questions are from this topic. Like this you are going to see the questions. So now how can you answer all these things? I will give you some very simple tricks, you just follow them. Like methane I am writing, water and NH3 I am writing. Let's start with very basics. Carbon, which group it is? Which group element it is? 14th group. Valence electrons are how many? 4. You take 4 dots. Hydrogens are how many? 4. So, one bond required 2 electrons. 1 electron from hydrogen, 1 electron from. So, like this. How many sigma bonds we got? 4. So, 4 sigma bonds we got. See, only 2 sigma bonds if we got. 2 sigma bonds means sp. 3 sigma bonds? 4 sigma bonds? What I am saying, all the time I am using S sigma bonds. Okay. So now these numbers are called steric numbers. What is this? Steric numbers. So steric number is equals to steric number or hybridization number. What is that? Hybridization number is equals to number of sigma bonds plus number of lone pair electrons. What is that? So here we got 4 now. 4 means what it is? sp3. Okay. The next you tell me for this water molecule. How do you do? Oxygen is a central atom. 6. Put 6 dots. Next, hydrogens are how many? 2 sigma bonds. Then this is one set, this is second set. Total how many? 1, 2, 3, 4. So 4 means again sp3. Next this one? 5 dots.
3 hydrogen atoms.
So what happens? 3. Next this is one lone pair. So this is also sp3. Now let's move forward with SO2. Do it for this. Six now. Next. But oxygen is monovalent or divalent?
Divalent.
Why you are saying it as divalent? Because it has 6 valence electrons. How many is still required? 2 more required. That's why it try to make 2 bonds. Okay. So if it is making 1 bond, 6 electrons previously, 1 bond means 7th electron came. Now 1 more is required. Now that's why it is sharing 1 more electron with other. Okay, like that. Okay. So now tell me how many sigma bonds you are seeing. 1 sigma, this is pi, this is sigma, this is pi. So, and this is one lone pair. So totally how many sigma bonds? 2 sigma bonds and 1 lone pair. So totally 2 plus 1. What is the total number you got? 3. 3 means sp2. Do you got how we are solving all these things? Okay. Entama? Sulfur contains how many valence electrons? 6. You put 6 dots. After that, oxygen is there now. Is it monovalent or divalent? Divalent means it makes 2 bonds. So for making 2 bonds, 2 electrons required from central atom. Like that, it is paired up. How many still remaining? 1 pair of electron, that is 1 lone pair. Here 1 sigma bond, here 1 sigma bond. Do not consider pi bonds. Okay, 2 sigma bonds plus 1 lone pair. So total number is 3. So it is sp2. Okay. Now tell me similarly for XeO F2. Fast. Xenon, which group element? So 18th group means 18th group means how many valence electrons? 8. Put 8 dots first. Tell me for this. This one. 8 na? Put 8 dots. Are xenon which group element ma? So put 8 dots. 3, 4, 7, 8. Now how many fluorines are there? Halogens means monovalent or divalent? Like 7 electrons are there in the valency. One more is required. So it means it make one bond. Like one fluorine, second fluorine. Oxygen makes like this. So how many sigma bonds you seen? 1, 2, 3. This is pi. Ignore it. Sorry. So what we got? 3 sigma bonds plus 2 lone pairs. So totally how much? 5. So 5 means if it is only 1, you should say S. If it is 2, you should say SP. If it is 3, you should say SP2. 4, 5, 3, D. Okay, so take these examples and you can try. Okay, first one SP. So one more trick also I will tell you here itself. See, you take this formula, hybridization number equals to its group number, what I am saying, group number of central atom plus number of monovalent atoms. What is that? Monovalent atoms by 2. What is that? Number of monovalent atoms. It means group number of xenon is how much ma? 8. How many monovalent atoms are there out of this? Is oxygen monovalent or divalent? Don't count it. Only monovalent. So 4 by 2. How much? 6. 12 by 2, 6. So 6 means what you are going to get? D2. So the same formula will applicable for all above discussion also. Okay, if you want you can try it for any of this example. So sulfur dioxide means how you will do? 6 plus divalent atoms only we have monovalent 0. So 0 by 2. 3. So 3 means sp2. sp2 here also we got. So both ways are perfect. Okay, you can do this way or that way. Okay. Done. Okay. So can take the break.